Mathematics 2, 2015 exam, question 6. The results of an experiment are given as follows. Draw a sketch of the data. A sketch can be quite rough, but the key things are that you've got the time across one axis, the correlation across the other axis, and the crosses in the right place. Part B. Taking those values as correct, calculate the Pearson correlation coefficient. I never trust anything, so I would check the ones that I can easily do. So sigma t is 0 plus 5 is 5, plus 10 is 15, plus 15 is 30, plus 20 is 50. So that's correct. 50 plus 30 is 80, plus 40 is 120, plus 30 is 150. So sigma c is correct as well. I'm not going to do the others, those two are correct. Let's remind ourselves of the Pearson formula. The correlation coefficient is given by that expression there. So I'm going to calculate the first bit there, which gives me 1250, and then the second bit gives me 7000. They're both positive, which is good because I need to take the square root, and if I put those values into this expression I get r equal to minus 8.5. Between minus 0.5 and 0.5 there is no correlation, so there's no point in continuing to calculate any kind of gradient. Less than minus 0.5 or greater than 0.5 is good correlation, so it is worth continuing, and in this case we've got strong negative correlation, which means we've got a line with a negative gradient. Part C. If the correlation coefficient implies there is a relationship, which there is, find the gradient and intercept of the line of best fit. Okay, we go back to the formula sheet where we find the gradient is given by this. Notice the denominator. The y-intercept is given by this expression. Again, notice the denominator. We've already calculated that. So putting the values in, we get the gradient is equal to minus 2 and the y-intercept is equal to 50. Part 2, add the line of best fit to your graph. Gradient of minus 2, y-intercept of 50. So that's good. And then part 3, state with reasons why you think your answer is correct. Well, I'm confident the answer is correct because the line goes through the middle of the data. There's data on both sides of the line and it's sort of equally spaced. If you look at the perpendiculars from the data to the line, the spacing is about the same. And that's the end of question 6.